Hi everyone, myself Siddharaju, Assistant Professor of Chemistry. Here I am going to discuss about one of the important chapters in physical chemistry, that is crystallography. It is for BSc third semester. In this session, I am going to discuss particularly about a definition of crystallography, types of solids, differences between crystalline and amorphous solids, crystal system and their characteristics. Let me consider each of them in detail. The first one is crystallography. Crystallography is a fancy word meaning the study of crystals, which means it is a branch of science that deals with the study of geometry, properties and structure of crystals and crystalline substances, which includes the principles that govern the growth of a crystal, internal structure and external shape of a crystal. So, to know much about the crystallography, it is needed to understand the physical states of a matter. As we know that matter can exist mainly in three different physical states. One is solid, another one is liquid and one more is a gas. Here it is needed to know much about the solid. It is directly related to the crystallography. Solids has the following characteristics. Solids have definite mass, volume and shape. The constituent particles have fixed positions and can only oscillate about their mean position. They cannot go out of the mean position. Intermolecular distances between the constituent particles are short. Intermolecular forces among the constituent particles are strong. Solids are incompressible and rigid. Then, how to classify the solids? On the basis of the nature of order present in the arrangement of their constituent particles, solids can be classified as crystalline solids and amorphous solids. Then what is meant by crystalline solids? This can be understood by looking at this picture. The arrangement of constituent particles in a crystalline solid is ordered. That means the arrangement of constituent particles follows a regular pattern and it is repetitive in three dimensions. Hence, it has definite geometrical shape. The best examples for the crystalline solids are sodium chloride, quartz, diamond, etc. Then what is meant by amorphous solids? Just have a look at this picture. The arrangement of constituent particles in an amorphous solid is not ordered. That means it is not following a particular pattern. Hence, it is having a irregular shape. The best examples for the amorphous solids are rubber, glass, plastic, etc. Then, what are the main differences between the crystalline solid and amorphous solids? Just have a look at this table. The first one, as we know that crystalline solids have definite geometry, whereas amorphous solids do not have definite geometry. That means they are having irregular shape. Crystalline solids have long range order, which means that there is a regular pattern of arrangement of particles. Just consider this. See, there is a regular pattern of arrangement of particles which repeats itself periodically over the entire crystal. See, the pattern is repetitive. This is what we call long range order. But amorphous solids have short range order. That means the regular pattern are scattered and in between the arrangement is disordered. So, this is what we call short range order. Crystalline solids have sharp melting point, whereas amorphous solids do not have sharp melting point. That is, they soften over a range of temperature. Crystalline solids shine in light and are considered to be true solids, whereas amorphous solids won't shine in light and are pseudo solids or supercooled liquids. See, the amorphous solids are called pseudo solids or supercooled liquid because the structure of amorphous solids are similar to the liquid. Then one more important difference between the crystalline and amorphous solids are these are anisotropic in nature, that is, their property vary with directions. That means, if you consider some of the physical properties such as refractive index, electrical conductivity, etc., they show different values when we measured along different directions in the same crystal. It is because of the different arrangement of particle in different directions. Just have a look at this. Here I have taken a two-dimensional arrangement of constituent particles in a crystal. See, when we measure the physical properties like refractive index, electrical conductivity in this direction, AB direction, it relates to a one kind of constituent particles. Whereas, when we measure along this direction, DC direction, it relates to two different kinds of constituent particle, hence the value changes. But in case of amorphous solids, these are isotropic in nature, that is, their property remains same in all direction. That means some of the physical properties like refractive index, electrical conductivity, etc., are same in all direction. It is because there is no long range order in them. Hence, the overall arrangement becomes equal in all directions. And one more important difference, they undergoes regular cleavage when they cut, but amorphous solids undergoes irregular cleavage when they cut. So, these are the main differences between the crystalline solids and amorphous solids. Now, let us consider one more important thing, crystal system and their characteristics. Here, I am going to take a portion of a crystal which represents the three-dimensional arrangement of constituent particles in space. This is what we call space lattice or crystal lattice. That is, the three-dimensional arrangement of particles in space is called space lattice or crystal lattice. Each point in the crystal lattice is called a lattice point. This lattice point represents the position of a constituent particle in the crystal. Then you consider this smallest portion. It is called a unit cell. It is a smallest repeating unit of a space lattice, which when repeated in 3 dimension, it produces entire crystal. So, this small portion is called a unit cell. Now, have a look at this unit cell. This unit cell is characterized by 6 parameters. Here I have considered A, B, C, A along the x direction, B along the y direction, C along the z direction, or x axis, y axis, z axis, and alpha, beta, gamma. See here the A, B, C, which represents the edge length. It is dimensions along the 3 edges A, B and C, and alpha, beta, gamma are the angle between the edges. Say alpha, it is between the edges B and C, beta, it is between the edges A and C, gamma is between the edges A and B. So, based on the value of these 6 parameters, a crystal system can be divided into 7 types. That means there are 7 types of crystal systems. It is based on the value of A, B, C, that is edge length, alpha, beta, gamma, that is angle between the edges. The 7 crystal systems are cubic system, tetragonal, orthorhombic, monoclinic, hexagonal, rhombohedral and triclinic. I am going to explain each of them in detail in my next classes. So, I hope you have understood about the definition of crystallography, types of solids, differences between the crystalline and amorphous solids, and crystal system and their characteristics. Thank you very much.